Download this code from codegive.com, link in the description below. Handling missing data and displaying items with no data, a comprehensive tutorial. Missing data is a pervasive problem in data analysis and software development. It can arise from various sources: sensor malfunctions, incomplete surveys, data entry errors, or simply cases where information is not applicable. Ignoring missing data can lead to biased results, inaccurate models, and ultimately, incorrect decisions. Therefore, it's crucial to understand how to handle it effectively. This tutorial will cover different strategies for displaying items even when their associated data is missing, using code examples in Python, with pandas for data manipulation, and JavaScript, for front-end display. We'll address different scenarios and provide practical solutions. Understanding the types of missing data. Before we dive into implementation, let's briefly categorize missing data to inform our choices. Missing completely at random, MCAR. The probability of data being missing is unrelated to both observed and unobserved data. This is the ideal, but least common, scenario. For example, if a survey application has a random bug causing some fields to be skipped. Missing at random, MAR. The probability of data being missing depends only on observed data, not on the missing data itself. For example, older users might be less likely to report their income. The missing income data then depends on the age, which is observed, not the income itself. Missing not at random, MNAR. The probability of data being missing depends on the missing data itself. For example, people with high incomes might be less likely to report their income because they want to avoid scrutiny. This is the most challenging type to handle because the missingness mechanism is related to the data we are trying to estimate. 2. Python, pandas, for data manipulation. Pandas provides powerful tools for dealing with missing data. Let's start with the basics. Representing missing data in pandas. Pandas uses nan, not a number, none, and nat, not a time, to represent missing values. Output B. Identifying missing values. Pandas provides functions to check for missing values. Output C. Strategies for displaying items with missing data. Our primary goal is to display all items, even if some data is missing. Here are several ways to achieve this. 1. Keep missing values as nan/none, and handle them in the front end. This approach involves passing the data frame, or a subset, as is to the front end. The front end logic then handles the display of nan or none values, example by displaying a placeholder, empty string, or specific message. This is often the best approach because it preserves information about which data is truly missing, allowing the front end to display it in a meaningful way. Output *. You can then send data _for front end to your JavaScript application. 2. Imputation with placeholder values *. You can replace missing values with a specific placeholder value. This is useful when you want to avoid nan or none in your data and have a default representation. Output *. Important *. Choose placeholder values carefully. 0 for numeric data might be misleading if 0 is a valid value. Consider using -1, none, or a descriptive string like unknown. 3. Conditional formatting based on missing data *. You might want to highlight rows or cells with missing data visually. This is particularly useful in data exploration. Pandas itself doesn't directly render HTML tables with conditional formatting in a web app, but it can generate the necessary styling instructions which you can then apply in the front end. This highlights missing values in yellow. You can pass the HTML string to your front end, but it's generally better to re-implement the styling logic using CSS classes applied based on the presence of missing data in the data you send from Python. This gives you more control over the appearance and allows you to separate concerns. Backend handles data, frontend handles presentation. D. Considerations for data imputation *. While filling missing values with placeholders can be useful for display, be cautious about using it for analysis. Imputation can introduce bias. For more sophisticated methods, consider using these. *mean/median imputation * replace missing numerical values with the mean or median of the column. *mode imputation * replace missing categorical values with the most frequent category. Regression imputation * use a regression model to predict the missing values based on other variables. Multiple imputation * generate multiple plausible datasets with imputed values and combine the results. This is a more advanced technique. Example of mean imputation *. Important * always document your imputation strategies and be aware of the potential biases they introduce. 3. JavaScript for front-end display. Now, let's look at how to handle missing data in the front end, assuming you've received data from your Python backend, likely in JSON format, which you can convert to JavaScript objects. A. Handling null/undefined in JavaScript *. JavaScript represents missing values as null or undefined. B. Displaying data in a table *. Here's a basic example using JavaScript to display data in an HTML table, handling missing values gracefully. Explanation *. 1. Data fetching, simulated. The data array simulates data received from the backend. In a real application, you'd use fetch or XML HTTP request to retrieve the data. This example assumes the backend sends back null values for missing data. 2. DOM manipulation *. The JavaScript code creates table rows, tr, and cells, td, dynamically and appends them to the table body, tbody. 3. Missing value handling * for each cell, it checks if the corresponding data value is null or undefined. If it is, it displays a placeholder string, example n/a, unknown, not disclosed. It also adds the class missing data to the cell, which allows you to style missing values differently, example in italics and gray color. 4. Conditional styling *. The CSS defines the missing data class to style cells containing missing data. See alternative front-end frameworks, React, Angular, Vue. Modern front-end frameworks provide more structured ways to handle data display and state management. Here's a simplified example using React. In this React example, the data table component receives the data as a prop. It uses data.map to iterate over the data and create table rows. The ternary operator, condition, value _if _true, value _if _false, is used to check for null or undefined values and display a placeholder accordingly. The class name attribute is conditionally set to missing data if the data is missing, allowing for styling. You can adapt this approach to Angular or Vue by using their respective templating and data binding mechanisms. The core idea remains the same: check for missing values and display a placeholder or apply a specific style. D. Considerations for user experience *. Clarity * make it clear to the user that data is missing. Avoid ambiguous placeholders. /a or not available are generally good choices. Consistency * use the same placeholder consistently throughout your application. Tooltip / explanation * consider adding a tooltip or explanation to missing values. For example, hovering over n/a could display data not available. Asterisk disable functionality asterisk if missing data prevents certain actions, example calculations, disable the related functionality and provide a clear explanation. Asterisk visual cues asterisk use visual cues, example italics, different colors, icons, to distinguish missing data from valid data. 4. Advanced strategies. Asterisk reporting missing data patterns asterisk provide a summary of missing data patterns to the user. For example, 20% of users have not provided their age. This helps users understand the limitations of the data. Asterisk allowing user input asterisk if possible, allow users to fill in missing data. Provide a clear interface for this. Asterisk data validation asterisk implement robust data validation to prevent missing data from being entered in the first place. Choosing the right approach. The best approach depends on several factors. Asterisk the type of missing data asterisk MCAR, MAR, or MNAR. Asterisk the purpose of the display asterisk is it for data exploration, reporting, or user interaction. Asterisk the size and complexity of the dataset asterisk for very large data sets, you might need to use more efficient algorithms. Asterisk the technical skills of your team asterisk choose methods that your team is comfortable with. In summary asterisk. Handling missing data is a crucial aspect of data analysis and software development. By understanding the different types of missing data, using appropriate data manipulation techniques in Python, pandas, and implementing thoughtful front-end display strategies in JavaScript, or other frameworks, you can create applications that handle missing data gracefully and provide a better user experience. The key is to be transparent about missing data and avoid making assumptions that could lead to incorrect interpretations or decisions. Always document your approach and be aware of the potential biases introduced by your chosen methods. Handling missing data and displaying items with no data, a comprehensive tutorial. Data is rarely perfect in the real world. It's common to encounter missing values, gaps, or incomplete records. Ignoring these missing values can lead to inaccurate analysis, biased conclusions, and a distorted view of reality. Therefore, handling missing data gracefully is a crucial skill for any data professional. This tutorial focuses on how to handle missing data and, importantly, even when data is missing, ensure that items with no data are still shown in your output or analysis. We'll cover different strategies, code examples in Python, using pandas, a popular data manipulation library, and discuss the trade-offs involved. Understanding the problem, types and causes of missing data. Before jumping into solutions, it's vital to understand the nature of missing data. Missing data isn't just a uniform void, it can arise for various reasons and have different implications. Asterisk missing completely at random, MCAR the probability of a value being missing is unrelated to both the observed and unobserved values. In other words, it's a completely random occurrence. For example, a server glitch that randomly caused some data entries to be lost. Asterisk missing at random, MAR the probability of a value being missing depends only on the observed data, not on the missing value itself. For example, in a survey, men might be less likely to report their weight than women. The missingness of weight depends on the observed gender. Asterisk missing not at random, MNAR the probability of a value being missing depends on the missing value itself. For example, individuals with high incomes might be less likely to disclose their income in a survey. The missingness of income is related to the income value. Why is understanding missingness important? The type of missingness influences the appropriate handling strategy. MCAR allows for simpler methods like complete case analysis, dropping rows with any missing data, although this can lead to loss of information if the missingness is widespread. MAR often requires more sophisticated techniques like imputation. MNAR is the trickiest because it's hard to account for the dependence on the unobserved value. 2. Strategies for handling missing data, and keeping items visible. Here's a breakdown of common approaches and how to ensure items with no data are still displayed. 1. Deletion, complete case analysis. Asterisk how it works. Asterisk removes rows or columns containing any missing values. Asterisk when to use. Asterisk only suitable if the amount of missing data is very small, example less than 5%, and is MCAR. Asterisk drawbacks. Asterisk can lead to significant loss of data and potential bias if the missing data is not MCAR. Fails to meet our primary objective of displaying items with no data. Asterisk code example, pandas. 2. Imputation. Asterisk. Asterisk how it works. Asterisk fills in missing values with estimated values. This is a much preferred approach over simple deletion. Asterisk types of imputation. Asterisk. Asterisk mean / median / mode. Imputation. Asterisk replaces missing values with the mean, median, or mode of the corresponding column. Simple to implement but can reduce variance and introduce bias. Asterisk constant value imputation. Asterisk replaces missing values with a fixed value, example 0, -1, missing. Useful when a specific value has a meaningful interpretation. Asterisk regression imputation. Asterisk uses regression models to predict missing values based on other variables. Asterisk k-nearest neighbors, KNN, imputation. Asterisk fills in missing values based on the values of similar data points. Asterisk multiple imputation. Asterisk creates multiple plausible data sets with different imputed values, reflecting the uncertainty around the imputation. More computationally intensive but provides more accurate estimates and standard errors. Asterisk how to show items with no data. Asterisk this is where imputation shines. We can ensure all items are displayed, even if we have to impute a placeholder value for their missing data. This allows you to represent all items, and then display an annotation that the value is imputed. Asterisk code example, pandas with mean / median / constant imputation. Asterisk code example, pandas with KNN imputation. Asterisk important considerations for imputation. Asterisk. Asterisk domain knowledge. Asterisk use your understanding of the data to choose the most appropriate imputation method. Asterisk bias. Asterisk imputation can introduce bias if done improperly. Asterisk uncertainty. Asterisk acknowledge the uncertainty introduced by imputation. Consider using multiple imputation if possible, especially for downstream statistical analysis. Asterisk documentation. Asterisk clearly document the imputation method used. 3. Creating indicator variables, dummy variables. Asterisk how it works. Asterisk create a new binary column, 0 or 1, indicating whether a value was missing in the original column. Asterisk when to use. Asterisk useful when the fact that a value is missing is itself informative. Asterisk how to show items with no data. Asterisk this ensures that all items are kept, while also indicating that data was originally missing. It doesn't fill the missing data, but it captures the information about its absence. Asterisk code example, pandas. 4. Representing missing values explicitly. Asterisk. Asterisk how it works. Asterisk instead of dropping or imputing, you can leave the missing values as they are, example nan in pandas, and handle them appropriately in your analysis or visualization. This maintains transparency. Asterisk how to show items with no data. Asterisk the key is to design your visualizations or reports to handle the nan values gracefully. For example, displaying n/a or missing instead of a blank space. Asterisk code example, visualization with Seaborn. 5. Outer joins / merges, crucial for showing items even with missing data. Asterisk how it works. Asterisk when combining data from multiple sources, use outer joins, left, right, or full outer joins, to ensure that all items from one or both sources are included in the result, even if there's no matching data in the other source. This is particularly important when some items exist in one dataset but have missing data in another dataset being merged. Asterisk when to use. Asterisk whenever you're combining data from multiple tables / data frames, and you want to guarantee that all items from one or both sources are represented, regardless of whether they have corresponding data in the other sources. Asterisk code example, pandas. In this example, even though items 2 and 4 don't have scores, they are still included in the df_merged data frame, with their score value being nan. This guarantees that all items are visible. You can then handle these nan values with imputation, indicator variables, or display them as missing as shown earlier. 3. Putting it all together, a complete example. Let's create a comprehensive example that demonstrates several techniques to handle missing data and display items with no data. In this example, 1. We start with items and sales data frames. Item 4 is missing from sales and item 3 and 5 have missing sales data. 2. We use a left outer join to ensure all items are kept, even those with no sales data. 3. We impute missing sales amount with 0, and create an indicator variable to track which values were imputed. 4. We use KNN to impute the missing units sold data. 5. We then visualize the data, highlighting the imputed values to make it clear which values were estimated. 6. Finally, we show how you can analyze the data while considering the original missingness. 4. Key considerations and best practices. Asterisk document everything. Asterisk thoroughly document your approach to handling missing data, including the reasons for choosing specific methods and any assumptions made. Asterisk understand the data. Asterisk gain a deep understanding of your data and the reasons for missingness. Asterisk test different methods. Asterisk experiment with different imputation and analysis techniques to assess their impact on your results. Asterisk communicate clearly. Asterisk when presenting your findings, be transparent about the presence of missing data and how it was handled. Asterisk avoid blindly applying techniques. Asterisk there is no one-size-fits-all solution. Carefully consider the characteristics of your data and the goals of your analysis. Asterisk be aware of potential biases. Asterisk introducing data by imputation changes the distribution, and depending on the model that is used it might skew the prediction, so you need to be aware of that. Conclusion. Handling missing data is a critical aspect of data analysis. By understanding the types of missingness, choosing appropriate handling strategies, especially imputation, and leveraging outer joins, you can ensure that all items are displayed, even those with missing data. Remember to carefully document your approach and communicate your findings transparently. This leads to more robust, reliable, and insightful data analysis. The provided examples demonstrate how to implement these techniques effectively using Pandas and Python. Good luck.